Welcome back to the next topic, students. Here, the haloarene and haloalkanes, the elimination reaction. It is dehydrohalogenation. Dehydro D means releasing without having a hydrogen and a halogen. Removal of hydrogen and halogen is called as a dehydrohalogenation. In E1 reaction, that is unimolecular elimination reaction, one for uni, two for a bimolecular. In unimolecular reaction, it is undergoes in two different steps. One in proton and leaving group of halogens depart into different groups. First, halogen groups is releases, it forms a carbocation. Here, the one example of CH3 like that, and here CH2 with one halogen. This CH3 may be RR group, whether it is a 2 alkyl group or 1 alkyl group or 3 alkyl, either primary or secondary or tertiary. Any example, elimination of proton from beta carbon. So the halogen attached carbon is called alpha carbon. Next to alpha is called as a beta. Next to beta, if carbon is there, gamma, next to gamma carbon is there, it is a delta. There are four positions in a hydrocarbons in aliphatic compounds. In this, here it is alpha carbon, next to carbon is called beta. There is abstraction in a beta carbon hydrogen and the elimination of halogen, both dehydrohalogenation. First step, halogen is released because the leaving group. So already I mentioned I minus is greater than Br minus greater than Cl minus greater than F minus. These are the order of the leaving group. So I minus is the best leaving group and fluorine is a very worst leaving group. So what and this order this is considered as a leaving group of any halogen, and halogen is going along with the bonded electron because it is a more electronegative. Already I mentioned fluorine has 4.0 electronegativity value, chlorine 3.0, bromine 2.8, iodine 2.5. So according to that electronegativity, there attracts the electron towards itself, so it acquires X minus and it gives a carbocation. So carbocation, whether it is a primary carbocation or secondary carbocation or tertiary carbocation, we should see them. If it is a tertiary carbocation, is more stable than secondary carbocation, is more stable than primary carbocation. Tertiary carbocation means only C plus. Secondary carbocation means CH plus. Primary carbocation will have two hydrogen, CH2. So this is a CH. So it is a secondary carbocation. Now after formation of carbocation, the abstraction of proton from the carbon next to carbon bearing halogen. This is called carbon bearing halogen. This is called as a halogen bear carbon. Next to that is called as a beta carbon. In beta carbon, this C plus, this cation is sharing the, taking the electron from the carbon. So carbon is going, hydrogen is going out from the next to alpha carbon, from beta carbon. The hydrogen is eliminated to this B minus. Any base is attached with this hydrogen, it forms as a BH. So here this bonded electron is shifted to this carbocation, so it forms a CH2 double bond CH2. It forms a alkene in even elimination. For example, CH3, CH2Br, ethyl bromide is the example. So in ethyl bromide, first carbon is called alpha carbon. It attached with bromine. And second is beta carbon. It contains three hydrogen, beta hydrogens. So alcoholic KOH. If it is alcoholic KOH, that is one of the concepts. If you use aqueous KOH, aqueous means water content KOH, we will get alcohol. If it is alcoholic KOH, we will get alkene. That is one of the two reasons of memorizing that medium of KOH. If it is an alcoholic, alkene is formed. If it is aqueous KOH, you will get a alcohol. That I will teach you in the next alcohol lessons. In a brief manner, how we are getting this alcohol and the alkene setup. Now we have used the medium of alcoholic medium in KOH. That KBr is first step is removal of KBr. Then it left out OH minus. This is called B minus. So this B minus is a base. So this OH minus abstract the proton. So it take out the proton. It is pick up the proton. It is not giving, it is coming and taking away this electron, because OH minus will have the tendency to attract plus. So this electron is shifted here because it becomes carbocation after losing Br. So this bonded electron will be go here, and immediately the H will be captured by OH. So we'll get a water. So this is called a CH2 double bond CH2. So this bonded electron shifted here means it becomes a new bond will be formed between carbon and carbon, CH2 double bond CH2. In this, the first step, it is removal of KBr. KBr will be released, and then second step, that water is the released. So these are the two steps to be taken in this general reaction. This is first thing is a elimination of halogen producing carbocation, and then this from the carbocation, this hydrogen is eliminated by base by accepting this bonded electron towards to satisfy neutralize this carbocation. Then we got the alkene. That base only we used a alcoholic KOH. Next, same thing I have written now. Br and abstraction of hydrogen. Not only this hydrogen, any one of the beta carbon attached hydrogen can be released, can be abstracted. So bimolecular elimination reaction, because E2 reaction, it is a bimolecular. Here beta hydrogen abstraction of proton from carbon next to the carbon bearing halogen atom form a new pi bond. The bond is called as a pi bond. So B is called as a base and X is called any leaving group, maybe I minus or Br minus or Cl minus, F minus. Again and again I'm repeating. It is MCQ. I minus is the best leaving group than other halogens. F minus is a very poor leaving group. So now 2-bromobutene is the largest number of alkyl group preferred by double bond according to the Z-SIF rule. So in this Z-SIF rule, what is the Z-SIF means? Maximum number of alkyl group should be attached to the double bonded carbon. Is called as a Z-SIF. So that carbon will be having the more stable. Already I given the Z-SIF rule alone in one of my video I given. You just go through the Z-SIF rule alone. Alkene with a greater number of alkyl group. Alkene means double bonded group should contain more number of alkyl group, means that are very stable according to the Z-SIF rule. Z-SIF is one of the scientists we discovered this. So what, to honor him, they said the name as a Z-SIF rule. So now let us take the CH3, CH2, CH, Br and CH3. So the halogen attached carbon only get a first preference, that is alpha carbon. Next to alpha carbon is called beta. Next to alpha another thing is called beta dash also we can consider. So both the carbons are beta beta. So now I use the alcoholic KOH. Already I told you, remember that if you use a KOH in two different medium, one is aqueous medium, we are getting a alcohol. In alcoholic medium, we are getting alkenes. Remember this. Whenever we see, we just to recall all the points again and again only, we will remember all the points. Only then we can answer it wherever it needs. In all MCQs and all, if there's a keen question will be observed, then you can answer it very easily. Just you recall the points then and there. If you have any stuck in your mind of remembering that what about this KOH with alcohol medium, aqueous medium is, just go through. Immediately you go through, turn the page and go through, and then you recall the points. Now let us see this. Alcoholic KOH is used by heating. It releasing the hydroboric acid. So HBr is moving. So here CH3, CH2, CHBr, CH3. In case this Br may take hydrogen from this beta carbon, or it may take a hydrogen to this beta carbon, not attested simultaneously, one by one. Either this nor this. Suppose if it takes hydrogen from here, that's what I released the HBr. After losing HBr, that hydrogen only alone going with the Br, it leaves the bonded electron and goes. So that bonded electron is form a pi bond. So what CH3? CH double bond CH, CH3. So here this CH double bond CH is called alkenes, or also we can call as olefins. So to this alkene, two alkyl groups are attached. Here one methyl and this is one methyl. So 2R is attached. So it is a 1, 1, 2, 3, 4. So butene, 2-butene or butene is a correct answer. So next I say this is a 80% ZC product because two alkyl groups are attached to double bond. Let us see the bromine, whether it is takes the hydrogen from this right side hydrogen means what happened, let us see. HBr is loses, in this hydrogen alone is goes, that attached bonded is donated to this carbocation, so we'll get a CH3, CH2, CH double bond CH2 will get it. So between this double bonded carbon, only one alkyl group is attached. CH3, CH2 is called ethyl. That is only one alkyl. So only one R is attached. Here 2R is attached. So I already told you that there is a Z-zip rule. That is a alkene with the greater number of alkyl group will have the more stable. So here two alkyl group instead of here one alkyl. So what it is 80%. 80% of the product is getting from the Z-zip rule. Only 20% is getting from the Hoffman's product. So this is called Z-zip product and this is called as a Hoffman's product. So this is very, very important question for the board exam. So characteristics of E1, two-step process. That is E1 will take, now we are going to compare E1 and E2. So that is two-step process is called E1, that is first order reaction, because rate of the reaction is directly proportional to alkyl halides. So because only one alkyl halides concentration terms, the proportionality constant is K, the new pi bond is formed, so the rearrangement is possible. So errors in E2 character, single step process, second order reaction. So it is depends upon both alkyl halide and a B minus. So minus B minus is base. The rearrangement is not possible at all. So now let us see the reaction with the active metals. So what are the active metals? Grignard reagent with the magnesium, with the dry ether. We are getting RMgX. So Rx is the alkyl halide. Mg is the one of the only one metal to be used. Only then we can call it as a Grignard reagent. R alkyl group, Mg magnesium, X is any halogen. So it is in presence of dry ether medium to be used in order to dissolve solvation of halogen groups in order to bring back very easily. So what the RMgX is a Grignard reagent. Organometallic compound, any other metals are present, it is called organometallic compound. In case of lithium, sodium, potassium like that, if it is present, it is called as an organometallic compound. It is not considered as a reagent, right? Grignard reagent. Only one magnesium is attached with the alkyl group and halogen group or called as a Grignard reagent. So CH3, CH2, Br. With Mg in presence of dry ether, it forms a CH3, CH2, MgBr. So let us see here Woods reaction. In this Woods reaction, Rx and another Rx. I mean one alkyl group and this is another alkyl group. 1 minute. So two different types of alkyl halogens to be taken. One Rx, another Rx. In presence of sodium to sodium metal and dry ether we are using. So the two Na, I mean one NaX, another NaX, so R and R dash, we will get a alkanes. So now Curie-House reaction. Curie-House reaction is nothing but four scientists are made this equation, so they are called as a Curie-House because of this four scientists' names are Curie is the first scientist. Forstner is the second scientist. Whiteside is the third one. The fourth one is a Hauser, or called as a Curie-Hauser reaction. Very, very important in MCQs and NCRT and even NEET and JEE exam, they will often use to ask based on Kurehaus reaction. There are the two steps are there, that alkyl halogen, that steps is very, very important. What are the two steps? You just to see that. 1 minute, please. I'll reduce it. Okay. Alkyl halogen, react with the very active metals like lithium is the very best active metal and solvated by the dry ether or LIS compound. And second step, alkyl lithium compound to be treated with the cuprous halide to form a dialkyl cuprate lithium. Dialkyl cuprate lithium. These two steps are very, very important while you writing the reaction. Whenever you write an organic reaction, you should remember statement is very, very important. Only the marks for a 1 mark or half mark will be given for the only the statements. Now I am going to say you what is active metals and what is less active metals. Just to see this one, no? This combination, this is for you to remember. I myself have written here, that is like Kanaka, Megal Singh Feb. He is the name. Like Kanaka, Megal Singh Feb. So like Kanaka, Megal Singh Feb, like that you say for several times. He is the name. Like Kanaka, Megal Singh Feb, they are going to Hajj. H is a Hajj. Hajj Mecca. They are going to Mecca. There they are standing in queue. So that is copper is CQ. It is a Q hug. Mercury hug. Silver gold. Hajj Q hug. Hug silver gold. Like Kanaka, Meghal Singh Feb, Hajj Q hug silver gold. Like that you memorize this in the same order, because up to Megal, it's a more reactive. Lithium is a very, very active. And then next, gradually the order is decreases. So actually Na should come before Ca should come before Na. But for remembrance, active metals I have written in this like Kanaka, Megal, but all other things are correct order. Like Kanaka, Meghal Singh Feb, Al up to Al, Mehal, more reactive. Then Singh, Feb, they are less reactive. Hydrogen is the base, 0.00 voltage. But all other are minus voltage. These are plus voltage. Then later on I'll explain you that is a standard reduction potential, negative and positive. Later on we will explain that. Here it is a Cu. Q, hug, silver, gold, same order, don't change order. It is a very least reactive. So more reactive, these three are less reactive, these four are the very least reactive. So what we have taken a active metal of lithium. First we have chosen in a Kurehaus reaction. So sodium is a active metal, magnesium is the active metal, calcium is the active metal, potassium is the active metal, aluminium is the more active metal. So now Kurehaus reaction, it takes place, I said, it has first two steps is carries. First one, alkyl halogen is reacted with a very active metal of lithium to Li. In the priority of periodic table, which is very active metal, means lithium alone is a very, very active metal. Then in presence of dry ether is a solvent for lithium. So we are getting RLi, two lithium I have chosen. So one lithium is lithium halogen, another one is linked with the alkyl group. So Li and Lix is the lithium halogen. This is alkyl lithium. First step is formation of alkyl lithium. Second step, 2 alkyl lithium are reacted with cuprous halides, any cuprous halide. So first it loses Lix. First step Lix released, second step also Li is released. So here it has 2 Li. One Li is removed. So left out R2 Li. So this R2 Li, this copper is linked. So that is called R2Cu Li. Dialkyl cuprate lithium, two-step process. This dialkyl cuprate lithium is a 1 mark in MCQ, often in an NEET also they are asking, this is called Gilman's reagent. It is called as a Gilman's reagent. Gilman's reagent. Dialkyl cuprate lithium is called Gilman's reagent. Once again, dialkyl cuprate lithium called Gilman's reagent. This Gilman's reagent is again reacted with the either the same alkyl halogen or different alkyl halogen. We will get alkenes. This R and this R dash combines alkane. Then one R remain left out. This is along with the Cu alkyl cuprate plus lithium halogen. So we can prepare any kind of alkanes can be prepared by using Curie-House reaction. I have given a homework to you because in this way only in NEET exams, will not only NEET exam, even in NCRT also, they will give you an example 1, 2, 3, 4 butane with the 1 methyl, 2 methyl butane. So they will give a 2 methyl butane is given. If it are having this cleavage here, I mean this is make into 2 alkyl group and apply this Curie-House reaction and work out and find out the answer. So may prepare unsymmetrical alkanes also called as a Curie-House reaction, coupling of alkyl groups of 2 alkyl halide to produce a alkanes. So it is a general formula. Rx plus R dash X gives a R dash. Now let us see the reduction reactions. Very, very important. Final, we are coming to the reactions of this haloalkanes. So in this reduction reaction, CH3, CH2Br, reduction means addition of hydrogen. We are having variety of reagents. One reagent is a metal, I mean 2 metals, zinc and copper or nickel and palladium or platinum, palladium. Like that, if it is 2 metals are coupled, it produces hydrogen. Then Hi with the red phosphorus. Whenever you add hydroiodic acid, we should add a red phosphorus in order to remove the hydrogen. In one of the alcohol lesson, I will explain you this how they are reacting this red phosphorus to release the hydrogen iodide. So hydroiodic acid, whenever you use red phosphorus to be used, or zinc couple is used, or tin and HCl, you take a beaker of hydrochloric acid and immerse the zinc rod in, I mean tin rod, you immerse it, immediately it gives the hydrogen. So that hydrogen is captured for the reduction reaction. Or nickel or palladium, the temperature is 525 Kelvin. These are the different reducing agents. Whatever the reducing agent to be used, we are getting this compound is same. Ethane, ethane, ethane. Here this bond gets break. Here hydrogen, here hydrogen. So we'll get a CH3, single bond CH3 and HBr. So CH3, single bond CH3. In short, we can write C2H6, C2H6, C2H6. Thank you, students.